Hey there, and welcome to this video on variadic functions. Now, this particular concept, variadic functions, is critical and surely the most important function concept that you need to understand to be able to implement your printf project. Without understanding of this concept on variadic functions, it becomes, I believe, almost impossible to create your own printf function. So let's start by just doing a quick refresher on what functions are and how we declare those functions and how we define them, just to understand what goes in there. So I am going to open a file called main.h that I had already created. It doesn't have anything inside. We can just see it has the guard. It's just guarded so that we do not duplicate or confuse our definitions. So in here, the first thing that we do with regular functions when we declare them is we start with the return type of that particular function. So in this case, we are going to create a function called sum that returns the sum of two integers which are passed into it as the parameters. So the first thing that we do is the return type of this particular function and then the name of the function. So let's call it sum. And then this particular function takes in two parameters. The first integer we're just going to call a, and then the second one called b, and then we close that line with a semicolon. This is called a declaration. So this is a function declaration, and what we have here is the function signature or the prototype of the particular function, and this is how it looks like. Now if we wanted now to define this particular function, we are going to create a new file. So I am here in just my navigating using Vim, and then let's create a sum.c file. Now if we can describe what this file does, sum, this particular function returns the sum of the two integers passed as parameters. Okay, and then it has two parameters that go into it. We have a, which is first integer, and then we do have b, which is the second integer, and it returns sum of a and b. Okay, that's it for just the comments and describing a particular function. And as you can remember from its declaration, it returns an integer, the name is sum, and then we have int a and int b. And then let's now define the function. Okay, now in defining what it does, we can simply say return a plus b. Right, we are familiar with function, and this is now what it's called, the function, the definition of that particular function. Just wanted to introduce that, and so that we are clear. So this is the return type, the name of the function, the parameters inside this particular function. In this case, we have two parameters, a and b, and the types, the corresponding types also go there, and then whatever we want to do with our function, within our function, and manipulating the parameters as we've received them. That was quite easy, and I believe if you have any questions or if none of this makes sense, take your time and just go through functions and how we've been working with functions. Now let's go to variadic functions. Now variadic functions differ from regular functions in this main particular way, and that is variadic functions take in a variable number of parameters or arguments. In our case here with this function sum, we can clearly see that this function takes in a and b as its parameters and then manipulates them or works with them inside the function itself. If I was to, let's say, call this particular function and did something like this, so let me create a main.c file which is now going to be the main driver of this particular, to test our code and to test our function. So main, this is the entry point, and no parameters, and then return always 0 for success, right? So our main function returns an integer, the name is main, and it takes no parameters. And then let's close this particular function. Now we want to use the function that we just declared, and that is the sum function, and we declared it in our main.h file. So we import that, and then we also include our standard IO file just to help us print and look at the results that we get. So inside this function, let's have an integer variable called sum. So we've declared it, and then we say sum is equals to, oh, we can't use sum because the names are very similar to the one of our function. Let's call it answer. So we say our answer equals to sum, and then the first integer will be 2 and the second integer will be 3. From our basic mathematics, we know that this answer needs to be 5, so we need to see if our function actually works correctly. So we could now print this particular answer, and we see what we get, and that's how we use our printf function. The D is an identifier to help us, just know the format or the type of the parameter passed, and we are going to return 0. Now if we head over to our terminal and compile this, I will not use any flags at this point, so we're going to use GCC, and we are compiling sum and main.c, and our output file is going to be called sum. Let's just call it sum. Ooh, there's a problem here. Oh, I had a typo. I'm really sorry. I'm really sorry. This should be return 0. Now if we compile this particular program, so we are compiling the sum file and our main.c file with the output called sum. If we run the program sum, we see that the answer is 5, and that is what we were expecting because we passed 2 and 3 as the parameters, right? We can clearly see how that works. Now to the point that I was intending to make, if we go to our header file, if I, for instance, wanted to add a third number to add in a particular program and added 7, there is no way that our function knows that it's going to receive a third parameter or a third argument, and this is going to throw an error. And just to prove my point, if we compile these two at this point, sum.c and our main.c, and we output it to a file called sum, we see that there is an error, and the error is too many arguments to function sum. So how can we solve this particular problem? This is where variadic functions come in. So we can clear this, and then let's now just jump straight to understanding what variadic functions are. So variadic functions are functions that accept a variable number of parameters. That means it's not fixed to just say 1 or 2 or just 3 parameters, but a variable number. And this becomes very useful and helps us create very interesting and powerful programs. So let's just jump straight, and I'll show you what we can do with this. So let's create a new file. I'm going to call this file variadic sum.c, and we are going to recreate our sum function, but this way with the principles and the understanding of variadic functions. So I'm just going to reiterate again, variadic functions are functions that take in a variable number of parameters. That means you could pass 2 parameters, 4 parameters, 5 parameters, depending on how you've declared that function and defined it. So let's go to our header file and do a declaration for our variadic sum function. So we'll call it variadic sum. It takes in parameters, yes. It's a variable number of parameters, yes. So do we just leave it like that? What do we do? This is where now we realize that this function actually differs from our regular functions. Now, a variadic function in C has to have at least one parameter, one defined parameter, a parameter that we know. And the reason we have this one parameter is just, it's a special one. And this parameter should help us, understand or help us know how to manipulate the other parameters that come in. It's special in that way because, it should help us know how to deal with the other parameters that might be passed into this number. Now, in a variadic sum parameter, we could have the first parameter called count. And this parameter, really what it does, it gives us the count of all the other parameters, that are added into this particular function. So if we want to pass 4 parameters to add 4 numbers together, our first parameter is reserved to be that count of 4 to help us understand how the other, that we know that we do have 4 other parameters coming in. Now, I'm not saying that the first parameter is always count and an integer that tells us how many other parameters there are. It's just that in our case, the count of the other parameters that we need to work with is important for us to, work with our code, in a meaningful way. So in this case, we choose count. But as you can see in a printf function, which is also a variadic function, the first parameter to be received is usually called format, and that's just a way to help us understand how to format the other parameters and print them out to the console. We will jump to that, but this is just a brief explanation to help you understand that this first parameter is special, and it's special because it helps us at least get a glimpse of how to deal with any other parameters that we may receive. In our case, we are going to use count because that's as straightforward as it can get. Now, what do we put to indicate that this function also takes in, a variable number of other parameters? Do we rewrite int param1, int param2? But we don't know. Someone might pass in 1 parameter, someone might pass in 100. We do not know. Now, because we do not know, this special ellipsis is what we use to help the compiler understand that this is a variadic function. It may take more than just 1 parameter. This is the declaration of our variadic sum function. Now let's head over to its definition and let's define it. So I'm going to create a file called variadic sum.c, and in this file I'm going to describe what this particular function does. So returns the sum of all the parameters passed into it. Okay, it does have a parameter called count, and this is an integer that represents the count of parameters passed, or I can say the number of parameters passed into the function, and it returns sum of all params, which is an int. I think that's a sufficient description of a variadic sum function. As you can remember from our declaration, the prototype of the function, it returns an integer. The name is variadic sum, and it takes in a mandatory first argument called count and a variable number of other arguments. Now, this is where we come to the next problem that we are facing. How do we even access the other parameters? We've not given them names in which we can access it. Do we just write the ellipses? Now, this is where I need to introduce you to a header file called the stdarg.h, or I believe it's just short for standard arguments.h. So let's include that header file first. And this header file does multiple of things, a number of things. The first, it defines a special type called VA list. And this type is a list of all the parameters passed into our variadic function. And how we deal with the VA list, this particular special type, is that we can come here and declare a VA list type and then give it a name. So we could call it list, but a convention in the industry, and you will see this a lot in the wild, is to call it AP, right? But we could call it anything. Let's just go with list. I just wanted to make that clarification. So again, a VA list type is a list that contains all the other parameters passed into it. With that knowledge, then okay, do we just start working on the list? This was just the declaration of the list. To initialize that particular list, the std_arg header file also has another special macro defined in it. Think of a macro just as a function that does multiple things. So that particular macro is VA start. And what VA start does is just tells the VA list to understand, or helps it understand where exactly to start adding the elements to the list. And then it puts all the other elements after that, into that particular list. I hope that makes sense. It tells the list which parameter to start on, and then adds the other parameters after that particular one that we've indicated, to that particular list. So in this case, if I have VA start, it takes in two arguments. The first one is the list itself that we just declared up there of type VA list, and then the parameter that we are aware of, and we want the list to contain all the other parameters after it. So when we say VA start, pass in the list and say count, what that means is that after count, all the other parameters that will be passed in this particular function are going to be included and added into the VA list. So that's the other special macro that we use in variadic functions, VA start. Another special one is VA end. And what this does is that it frees the list, because when you create a list and all these other things inside, it takes space in memory. And as responsible programmers, we have to free that memory so that we can return it to the operating system for it to to do with other programs that require that particular memory. So VA end ensures that we free the list out in memory. Okay, so these are three items that are included in the std_arg.h header file. But these are not all the items. If we wanted now to access the particular elements, the particular parameters that were passed, there's another final one that we can use from here. Not really final, there's another one, but for the purpose of this video, this is just what I'm going to illustrate, and that is VA_arg. And this one, what this one does, it gets the next argument in the list. Every time we call VA_arg, it gets the next one and the next one. So it will start with the first one, then go to the next one, the next one. And it takes two parameters. It takes in a list, and it also takes in the expected type of that particular parameter. In our case, we know we are summing up integers, so we pass the type int and close that. By doing this, it understands that it starts at count. So when we call VA_arg, it now goes to the next parameter, which we do not know of. And if it's the last one, it's going to be null. Okay, it's going to be null. Now this one just calls the first parameter, but we don't know how many parameters there are. So we need to, figure out a way in calling it multiple times until we get to our final particular parameter. To do so, we could just take the simple approach of using a for loop. To do this, I'm going to declare an integer, and I'm just going to call it I. I don't know why we love using I. Maybe it stands for iterator, whatever, but it's just an interesting thing I've noticed. And then we're going to create a for loop, and we're going to initialize I with 0, and then say as I is less than count. This is where that count parameter becomes very, very important, because the count gives us a clear indicator of how many parameters have been passed in this function, and by doing so we assure that we are never going to run out of memory, or maybe just access a tiny number of parameters. So by passing in count, we'll know how many parameters have been passed, and we iterate that many times, and after every iteration we increment I. And then inside the for loop we are going to call va_arg. So this one is going to call va_arg as many times as the parameters are been passed in the particular function. If, for instance, I passed 4 parameters, this va_arg will be called 4 times, and it will help us just understand that. So I hope that is very clear. And now, because we want to sum all these particular things, we could have another integer called sum, and start sum at 0, and I'll just put it over here so that at the beginning of the for loop our sum is also 0, and then after every call of va_arg we increment sum by the value of va_arg. So we do sum plus equals va_arg list int. Okay, good. I hope we're clear up to this point. So by doing so, you can see that sum plus equals va_arg, the number of times that is going to be called, sum is just going to increment, 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 increment. And eventually, once we are done with that loop, we are going to return sum as our particular value for this particular function. So now, just to take a quick recap on what we have done, I know I have introduced a lot of concepts. We have variadic sum, our variadic function. We have VA list, a special type that is described or defined in the standard arg.h, std_arg.h. And this particular list will hold all the parameters that have been passed in this particular function. We have 2 integers over here, I and sum, which I is used for iteration purposes, the number of times you're going to iterate as we go through all the parameters, and sum just accumulates, is an accumulator that now adds all these other parameters together, and we're eventually going to return sum. We have VA start, a macro defined again in std_arg.h, and VA start just tells stores the parameters passed in this particular list, and starts takes in 2 values, the VA list type and the parameter that is up there, where to start this list from. Then we are looping by initiating I and sum at 0, and we're going to loop count number of times, because count is special in this case, just to tell us how many other parameters have been passed in this particular case. We increment I after every call, every for loop, and inside the for loop, every iteration just increments the value of va_arg, which again a special macro from the std_arg header file that gets the value of the argument, and it takes in 2 parameters, the list and the expected type of the next argument. Okay, so in this case it's an integer. And just before we close and say we are done with whatever we are doing, we have to free the list from memory, and we call va_end, another special macro from the std_arg header file, and we return sum. Now if we go to our main.c file, which helps us just drive this, we need to print the answer. That's true. So we're just going to declare an integer variable called ans, and that's going to hold our answer. And then we say answer is equals to variadic sum, and then we pass the count of numbers that we want. So let's say we want to pass 3 parameters. So we have 3. The first number is 1, the second one is 2, the other one is 3. So what this is going to, if we define, we remember that this count is what we've actually defined in when we're declaring the function. And this count just tells us the count of other numbers, the count of the other parameters that we are passing. And then now we just pass 3 other parameters, right? 1, 2, 3. This answer should give us 6. So let's head over and compile this particular program and see if this is going to give us that particular answer. So we're going to compile this program and output it in a program called Variadic. We run it, it compiles successfully, and if we run Variadic, we get that our answer is 6. Let's do another example with the main.c file, and this time let's pass 5 other numbers, 5 other parameters. We have 5, 1, 2, 3, and then let's do a 2 and a 1. So these are 5 parameters, 1, 2, 3, 2, and 1. The count is going to go through all of that, our count being 5, these are 5 numbers. So what is the expected value of this? It should be 9. So let's compile this again. Variadic sum.c is where our function is contained, our main.c, and let's output it to Variadic. And if we run this particular program, you can see that the answer is 9, exactly what we expected. I hope this quick description of the Variadic function has helped you, and you can get that core understanding of how to work with Variadic functions from here. Now your challenge here is to think of that first parameter that we passed into our Variadic function. In our case, we passed count, and it was simply straightforward the count of the other parameters that we are passing. Just think of using a string instead of an integer count, and how we might go through that string to understand what other parameters or how many parameters have been passed into our function. That's just a nudge towards the direction, because that's exactly what you're going to do with the printf function. I hope it helps you. In case of any questions, just make sure to ask. Thank you.